Maybe you will be lucky to hear his story about how he started his business when he was working at Google as big data engineer and later with different companies for different projects as a consultant. He started having this burning question and keeping him and his co-founder sleeping well at night. And they created this tool, Mona, and yeah, now he's here to tell us about his experiences. Thank you.
Thanks, Elif. Hey everyone, thanks for joining the talk. I'm not going to talk directly about Mona, at least not too much. I'll start with a little bit of extension for the introduction over here, right? So like Elif said, I started my career at Google, where I was a big data engineer and later a senior tech lead on the Google Trends team. If anyone isn't familiar, Google Trends is a really great analytics product on top of Google search data. Highly recommend you try it out. Later, I did some consultancy work, mainly around computer vision, and started founding my own companies. I actually also founded a restaurant. It's here in Berlin. So if anyone has dinner opportunity, it's a nice little vegan spot called Lia's Kitchen in Prenzlauer Berg. But most importantly for this talk, in the last 3.5 years or so, I've been acting as the co-founder and the chief product officer of Mona. And Mona is an observability and monitoring platform for AI in production. Its job is to find for you issues in your AI before, exactly where they happen, give you all the information you need before they hurt your business KPIs. And working on Mona really gave me this really great opportunity to meet really incredible AI teams. We have customers from like small starting AI-based like startups all the way to Fortune 500 companies and government organizations. And all of them are going through this very interesting transition from being very research-oriented in their thinking to being much more product-oriented in their thinking and making sure that the AI they're building is actually bringing value and their businesses can rely on that AI. And this gave me this really great opportunity and great vantage point to see what works and what doesn't when going through such a transition. So that's the main thing I'm going to talk about today. But maybe let's start with a little short story. In 2008, Google had this really great idea that utilizing Google search data on top of the Google Trends platform and combining that with data from the CDC, they could predict flu outbreaks across the US. And indeed, a model was built and actually showed really great results for the first couple of years, predicting the flu 10 days before the CDC could know that it's coming, showing really potential for life-saving implications. So this became like the poster child of data science, both within Google and across the industry, only to epically fail a couple of years later. It overpredicted like the flu cases in tens of percent, and this actually was outed by an article in Science magazine, so a third party, and it really very quickly became from the poster child of data science to the poster child of data science failure, or at least challenges, as you can see in the headlines over here. And one really wants to ask the question, why did this happen? And we can take a couple of perspectives to try to understand why this happened, right? The first one could be a technical perspective, which I can tell you there was actually nothing wrong over there. All the servers were healthy, the data was healthy, models were being periodically retrained, everything worked as planned. Then there's the research perspective, and obviously there are research reasons why the models start failing. If you think about it, the way people search on Google changes very significantly across several years, and maybe retraining just doesn't do the trick anymore. And then I think, but lastly really, that the best kind of perspective to take over here is really methodology and cultural perspective. Because Google Flu Trends, at the core of it, I forgot I have this, was really considered to be a research project. And as a research project, it really produced really great research, right? But not such a good product. And I think it was a great anti-example for what we see today to be perhaps the most important trend in the AI industry, which is moving towards a product-oriented approach to AI as opposed to a research-oriented one. Because traditionally speaking, I think we can all agree, the data science work is very research-oriented. Even today, if we search for something like the data science lifecycle on Google, this is more or less the kind of visuals we're going to get. The data scientist's work is to understand a business problem, prepare a data set, train, test, deploy, right? The model is the end product, the end result of this process. And once deployed, it is thrown over this virtual fence to now become someone else's problem organizationally, perhaps someone from DevOps. And the data scientist's job is kind of over, right? And maybe you can go to your next project, maybe a whole different model doing something completely different, right? This results in really lack of clarity regarding who owns the model once in production. And later results in what we like to call monitoring by customer complaints. Really the first person to actually know that something bad is happening is the business stakeholder that actually sees business KPIs going down, right? And this is when you get someone shouting at you. I have a really great quote over here. It's a real quote from a data science lead in a software solutions company that will obviously remain unnamed for the purpose of this talk. But he told me, he said, Itai, it's fine. When the model's performance starts to deteriorate, the customer shouts at our business people. So they're the ones who care the most about these kinds of issues. Even if you feel that this is a bit extreme, I can tell you that most teams that we encounter today are still not well prepared for evaluating and maintaining their AI over time. Issues are really only being handled when the business already feels the pain. And there are firefighting strategies being kind of implemented, and it's like a game of whack-a-mole where issues keep popping up and you kind of have to deal with them very quickly while business people and product people are breathing down your neck. And I do want to make it really clear over here that I'm not just talking about retraining, right? We see a lot of teams that are doing periodic retraining, automated, but still have these kind of underlying issues. Taking the business perspective, which is the most important perspective over here, into account, AI done this way is just considered risky business. It's hard enough to know whether you're going to get your money's worth when it comes to research project, but even if the research is successful, it's very hard to trust your AI later on to rely your business on it. And this in turn actually really hurts the data science teams and even threatens their existence, right? Because they're considered those research people who are doing something that's really cool for PR, but not something that you can actually like trust your business, rely your business on. So they're withheld central positions they could have had otherwise. Luckily, we can be optimistic. I think many organizations today realize this, and we see a very, very strong trend from this research-oriented thinking in AI to a more product-oriented thinking. So, I've been saying this term for a while now, product-oriented. Maybe it's time I'll try to define this, right? So let's give a general definition. What is it that we mean when we say product-oriented AI? The first thing we mean is that the model stops being the end product. Actually, it isn't even what matters. It's the whole AI-enabled system that matters. And we'll see really great examples for this in a second. The second thing is that the test of the model isn't in the test set anymore. It is continuous in production and given the business results that the model brings. In other words, the model needs to be evaluated in the context of the business function that it serves. And then lastly, your goal shifts, right? You strive to attend to system issues, which means both detecting them and resolving them before business KPIs are negatively impacted. Basically break the firefighting cycle, make sure that it break the monitoring by customer complaint cycle. I also want to take like 30 seconds and make sure that I'm not confusing anyone, that it's very clear that I'm not saying no more research, right? In fact, we're going to see that if you do product-oriented AI the right way, your research should improve. And the data scientist's job should definitely remain focused on research. And the second thing I want to make clear over here is that I'm not talking about a different trend that one can argue whether or not exists in the industry of you moving to more commoditized solutions that are already pre-made models with Vertex AI or SageMaker and you just connect the dots and you have an AI-based solution. Whether you're doing that or you have your own homegrown research-based models from scratch, in both cases, you can be much more research-oriented or much more product-oriented, and this transition is relevant. Okay, so with this introduction behind us, and we have like a good general idea what we mean when we say product-oriented AI, I want to dive more deeply into this topic. And to do that, I gathered 4 key concepts that, if taken into account correctly from our experience with all the teams that we're working with, those become the key factors in successfully getting product-oriented, right? Especially going through this transition. And throughout the remainder of the talk, what I'm going to do is go over all 4 of those and give you real-world examples from our customers' experience for how to approach them correctly and what makes them so important. The first one, which is also the most important one, being empowering the AI team to have end-to-end accountability for the entire AI-based system. This is a long sentence, it's a mouthful. So to kind of break it down, let's start with a real-world example for where this accountability kicks in. Imagine you have an e-commerce website, and in the center of that you have a search engine. And at the core of that search engine, there's a ranking model, right, that you're building. Maybe you have a training pipeline that runs every week and retrains that ranking model, right? Maybe there are several different versions for the ranking model, one for each country or each language of the user. And then in real time, when the user inserts a query, you get a top K result, and then the ranking model's job is to sort them, right? There's probably a server around this ranking model that decides which version to serve given the user query, right? For each query, there might be different, given the country, the build time, and maybe there's even a couple of environment variables in that serving cluster, in that server, that provide logic regarding which model version to choose. And now let's imagine that one of those environment variables in one of your serving clusters, for some reason, is outdated, is misconfigured, right? Now you have a certain percentage of your queries that are just being served by the wrong model and are getting the wrong results. How long do you think something like this can stay like undetected? Because nothing really appears broken to anyone, right? No one is really accountable for such things, and everything seems healthy. The business might not feel the pain for a while. A research-oriented data scientist will say something like, hey, are we talking about environment variables in our Kubernetes cluster in the serving time? I'm sorry, I built really great models, and if you just use the right one, you'll get really great results. I think this is DevOps. And the DevOps person, and obviously will be correct, right? And the DevOps person will say, yeah, this is on us. Maybe there was some miscommunication between us and the data science team. But those kind of issues, they're really inevitable in a production environment. How come nothing appears broken? All the requests get healthy responses, right? And then the business person was just going to be very frustrated, right? It's like, I invested all this money, I got top people, both in data science and in DevOps, and now no one can give me straight answers, and I'm not getting the value that I wanted. So, a product-oriented AI team would consider itself accountable, right, for the production time behavior of the system that's based on their model. I want to straight off the bat say over here that this doesn't mean that they are now in charge of building Kubernetes clusters and managing environment variables, right? But it does mean that they need to know, and actually the only ones that can know, they have the tools to know, if the system is malfunctioning on the data or algorithmic levels, which is exactly what happened over here, right? This isn't an easy thing, right? It's not an easy thing to do, right? Like, be accountable for such things. And the key term to do this correctly, organizationally, is empowerment. An organization that wants to have this kind of accountability must empower their AI team by adopting traditional software engineering and product management practices and skills, right? Making sure you have the right checklists and OKRs and measures, etc. By dedicating resources, both human and otherwise, especially on the engineering and operational layers, to the AI team to make them independent, make sure that they can iterate quickly, right, when such issues occur and can relaunch and understand what's happening. And then obviously have the right dedicated ML ops and infrastructure and tools to actually know that those things are happening and be able to iterate quickly as well. I'll finish this specific point with a great Entai quote. This is a quote that's a generalized quote that we hear all the time from many, many different data scientists in unempowered teams. You know that when you hear that they're not independent, they can't really do that work. They say something like, we have access to the data, but I'm waiting for the company's engineering team to create a cron job to run the relevant logic on it daily. I'm on their ticket queue, so this might take a while, right? That's an unempowered data scientist. Okay, finish with this first point, which I see it relates to a lot of people. Again, I think this is the most important point in the whole talk. If there's anything you're taking from this, I'm hoping it's this. But this leads us to the second point over here, for successfully going through this transition, becoming product-oriented, which is actually a very surprising point to many people until they hit this kind of wall, they find this kind of issue, which is to generate a granular understanding of the system's behavior, the key word here being granular, and not an overall one. And again, let's start with a real-world example for what I mean by this. So imagine you have a fraud detection system on transactions in an end-user bank account, right? That system gets features from many different sources. Some of them are derived from cookie data, right, on the end-user's browser, for example. Now assume, let's imagine that Google decides to release a new beta version to Chrome. And in this beta version, they're changing the policies for saving or reading cookies. Again, a true story. Now you have about 0.1% of your traffic using this beta version, which get really bad values for those features. And obviously, this same 0.1% is getting bad outputs from your model. If you wait for 2 or 3 months, then this will become 10% of your traffic. And then if you just track your feature distribution or output distribution, or wherever it is you're tracking, whatever metric, that's around when you're going to notice that there's a problem. But like I said before, what we're striving to do is to attend to these kind of issues before business KPIs are hurt, and obviously that will be way too late, right? So you need some kind of way to recognize that these kind of inevitable issues, they're recognized when they're very small. And we indeed like to call this example the growing pain example, right? It starts really small, but if you're not going to attend to this now, this is going to be a real pain. And there are many other examples for when such segmentation and granular understanding is really, really important, right? Maybe you have a small but really business critical segment, right? It's not very big in your sample data, but like a wealthy region that buys things on your e-commerce platform, but for a lot of money, right? You're interested in that even though they're a small amount of your data. There could be a divided world example, right? You have, like, you're serving 50 different customers, each one has their own data set, and this one customer doesn't really care that all the other customers are doing really great for them, right? And there could be any combination of those, could be multi-dimensional segments, could be unforeseen, very complex. And all I'm trying to say over here is that this is actually very difficult to do. You must have some kind of automatic and exhaustive system to find those kind of segments that are problematic. And the problem is once you try doing that in a naive approach, you get a lot of noise. And I can do a whole talk about how to avoid that mathematically and technically, and it's probably the most interesting thing that we worked on in Mona to solve. But just to put it out there, right? It's like you got to get granular. It's very hard to do because you're going to get really noisy. Okay, moving to our third point, third key factor in successfully getting product-oriented, which is zooming out from the model, taking the entire business context, right, and create KPIs that are related to the business, right? Evaluate your model in the context of the business function that it serves. And this is actually a very hard topic to discuss because business feedback is really like the problem child of AI. Sometimes you only have real business feedback much later in the process. Imagine you have a model trying to, predict real estate pricing, right, for 15 years from now because you want to make an investment. Even if it does exist, even if it exists right now, many times it's just like in another part of the organization, it belongs to the BI people or something, and it's kind of hard to get organizationally. Many times it is not a ground truth, a research-oriented ground truth, right? Imagine you have a recommendation engine and you're showing a specific ad to a user. Now you've biased the user's behavior and there's no way to tell whether or not, even if they clicked the ad, there's no way to tell whether you did the right job or not. And then to top all of that, business goals and KPIs, all the time they change, especially if you're in a startup. And you have to have really great communication between the research and the product team to make sure that you're on track. So there is no one-size-fits-all solution for this. I can just give you a couple of tips and examples from things that we saw working out for our customers. First of all, if feedback is really impossible to get, there are many other things that you can and definitely should monitor, from your output distributions all the way to different heuristics that you can create over here. Second thing, if you don't have immediate results, you can get creative sometimes with intermediate results, right? So if, for example, again, a real-world example over here, It happened to one of our customers. You're trying to predict lifetime value for, or not lifetime value, but just the user spend, right, for 1 year, for the first year on your platform, and you don't have a lot of information, and you don't want to wait a whole year to get to actually know whether or not you're doing well. So can the 1 month spend be a good proxy for this? Perhaps. Can you go deeper and perhaps having another model that predicts the 12 months, like the whole year spent, given the first month, right? Behavior and spend. Perhaps you can create something like this. This might sound tedious, but again, we want to create a measurable and testable kind of system over here to kind of adopt product management and software engineering practices. You're going to have to do that. You can do many more, right? You can predict after 2 months what's going to be in 10 months. And maybe this will actually be a bonus to your business as well, right? You have another prediction. And then this might sound trivial, but just I cannot stress enough how often we encounter this. If you do have this kind of business feedback, if it's possible for you physically to get it, do get it, and do monitor it in the context of the model run, right? You need to have that in the same place as your model outputs so that you can create the relevant loss functions and actually track how your model is behaving in that business context. And this might mean that you require some kind of asynchronous smart system of record, right? That you can tell it, hey, here are my model inputs and outputs. And then a week later, you can tell it, hey, remember this a week ago, what I told you about model inputs and outputs? Now I know some ground truth or manual labeling, or here it is, right? And you need to, this kind of thing to kind of join together very quickly and have like an ETL around it to create the metrics. It's not like a super difficult engineering job, but it's not trivial. Okay, approaching the end of the talk. I'm going to move to the fourth and last key factor in successfully getting product-oriented in AI, which is closing the loop and leveraging your newly obtained production visibility to improve research capabilities. And I like to call this factor the tide that raises all boats factor, because I think there's no better way to convince a research-oriented AI team to go product-oriented other than really showing it how much research has to gain and benefit from closing this gap, right? And I'm not talking just about more business outcomes and labels like we just saw in the previous examples, but also information, metadata, meta features that you might have in your product, in production. You might have control in your product in production to actually obtain this information that can help you with research, right? Again, let's take a real-world example. Imagine you are detecting language over audio files, right? And specifically, you're trying to detect German. I don't know how many German speakers are there here. I'm gonna give you an audio example in a second. So what do, right? You get a lot of conversations from some bank somewhere, right? And you hire some human German speaker labelers, right? To label those conversations, German or not German. And you train a model and you get a good test results. And now you release this into production. Now it's serving your users in your product, where you actually have a lot of control on what's happening, right? Over there, you can perhaps get a lot of metadata and information that you just couldn't get in your research phase. Right? For example, maybe in your product you have a way to get the geographical information for where at least region-wise, right? From where the conversation came, right? And then you can try to detect, right, your biases, right? If there are specific segments where there is some performance metric that you defined that's just performing worse on those specific segments. And those were undetectable in the research phase, right? So for example, in this real example, they found out that German detector just didn't work so well in northern Bavaria. I hope audio works, I don't know. And they brought back like the human labelers to listen to this to a couple of conversations, and it sounded something like this. Not working. No. Okay, you lost the North Bavarian dialect. I can tell you that I'm not a native German speaker. I do speak German though, and it was unintelligible to me. Obviously, for an AI system that wasn't trained on a specific dialect, this could really hurt performance. A cute story though over here. They also had another detector, another model, right, to detect music when in audio files, and the music detector actually got really high confidence scores for data, for the audio conversations coming from that region. So geographical information might be like super straightforward and clear when it comes to languages, right? Dialects, accents. But there could be many other factors that you can actually get in your product and utilize those, right? Some examples, again, from that real world example, the software that was used to record a conversation. Perhaps some softwares are using different encoding formats and this hurts your quality, right? The hardware that was used, right? Obviously, Apple decides to use a new version of a microphone in their new iPhones. This could cause something very different to come to your system, and maybe it's unprepared for this. Internet connectivity issues, right? All these kinds of information will probably not be there for you in the research phase, but there's definitely ways to get those kind of things in a real world product, right? All right, so just to summarize, I think we have just a couple of minutes left, so I'll just summarize this quickly. What we've been through. AI is traditionally done in a very research-oriented way, and this caused business to have a lot of risk with their investments on this, and they are realizing this and moving very strongly to a more product-oriented approach, which means measuring your AI-based system, not just the model, right, the entire system in the context of the business function that it serves, AKA the real world. And there are very specific organizational actions that you can take to increase chances of success going through this transition. Specifically, and most importantly, empower your AI team to adopt a culture of end-to-end accountability regarding the systems that they're building. Secondly, make sure that you have granular visibility and understanding of your system and the data flowing through it, and not just an overall kind of dashboard. Thirdly, make sure that you are evaluating your model in the context of the business function that it serves, right? Not on its own. And fourthly, that you close the loop and make sure that your research phase is now benefiting again from all this new value that you're getting in production. I hope you enjoyed the talk.
Thanks a lot.
Yeah, I have time for questions. I left, do feel free to like message me on LinkedIn. I'm like always happy to talk about these kind of things. And you can also reach me on our website. There are QR codes for both here. Feel free to use them.
Very practical. Thank you. So questions?
Yeah, so there's a poll in the way. You talked a lot about like...
Oh, there's a whole new side here.
End-to-end accountability for teams, which I agree with, but I think I see that as a bit more like once you already have started training, for example, and then basically from that stage on that you should have accountability. But can you talk a bit about how you see the step before that? So actually finding the use case and how, or if at all, you see how data science teams should be better integrated with like design thinking processes or something like that on the use case part and where that fits in this whole...
Finding the use case for AI, like why to build an AI-based product.
Exactly, yes. So, because I think too, a lot of like the more research teams are like, ooh, let's throw a neural network on this. This is cool. This is something I want to try. Actually, there's no like product need for that, right?
Yeah, I mean, I can give you an answer to be perfectly honest. I don't think I'm the best person to ask this question. I'm way better versed in what's happening once you have something and you want to like make sure that it brings real value to your product, but like the hypothesis is already there, right? For why you're doing this, right? I usually don't come in at a place where it's like, okay, we're just thinking, okay, we want to involve AI somewhere in our business. Where's the right places? So yeah, I don't know. I think maybe I'm just not the right person to ask this. To be completely fair, sorry. I can say what my intuition like what I feel like intuitively, but yeah. You should go definitely see Noah's talk for sure. Yeah. Yeah. Sorry.
Hi. Thanks for the talk. On this idea of a product-oriented team, I was wondering if you ever observed pushback from data scientists. into getting integrated.
Oh.
There's a lot of,
Yeah, for sure. There's pushback from all around, right? There's pushback from data scientists. They don't want to handle dashboards and they don't want to start getting alerts, right? And they like it that engineers do on call and they don't. And there's pushback also from business people, mainly if they didn't see a lot of value coming from the AI so far. So it's hard for them to like invest. Oh, we need like a whole like addition to the AI team now with people. And so I would say two things about the data science team. First of all, I did like a whole point about like closing the loop over here, making sure that the research benefits from this. And like the first customers that we had were championed by head of AI, right? The head of data science, head of AI, head of ML, who realized that their jobs, right, their team's existence is really in jeopardy because they're producing really cool research, but if they're going to do like, if there's going to be one, if they're going to F up, in one little thing in production, then it might be the end of it. Right? And we saw several talks about like when this is happening. And when they realized that, okay, this is like the right way to save my team is actually to make sure that at least we have trust in what's happening over here. Second thing is that this really benefits the research part. Again, right, having this product, this built into production. And lastly, I would say, do note that I did mention adding to the AI team, right, relevant resources, human and otherwise, specifically in engineering and operations. So it's not the data scientist's job. You're not extending the data scientist's job to now like be on call and like all the time look at dashboards and tracking alerts. You are telling them, oh, you're building a model. It's just like any other engineering component. You must have a monitoring playbook for this. You must tell us how can this go wrong, and what do anyone needs to do about it. And we'll call you when we escalate this and no one knows what to do, right? So there really shouldn't be any pushback. It's all about like saving your job, making sure that you're actually bringing value and not just doing research. I hope it helps. Yeah.
To follow up, so and how do you handle the pushback from the engineering colleagues? Because I had the same, anything that is not an alert, which is an immediate technical system related to data or model is like a hard no, usually. Mm-hmm. And a second question, you mentioned that many companies feel the pain. In my experience, I've seen a lot that the companies, I would be interested like which companies feel the pain, because I've seen a lot that they don't feel the pain because they don't know. Like if you imagine a backend system that no one would be monitoring for specific failures, and then maybe 5% or 10% of the customers who maybe can't call or are not aware that in the backend, like they didn't get the loan because the machine learning was like 10% wrong, or maybe this was just a made up example, obviously. Mm-hmm. And, or in recommender system, like if the reco is terrible, or we had this case where let's say a size recommender was wrong and all the oversized customers saw exactly the same fallback, but like no customer's gonna call and say, excuse me, on all the pages, it's like, so no one feels the pain. How do you handle that there is no problem solving pressure?
All right, so I'll take the first one first. How do you handle pushback from the engineering team? I think like the most straight answer is that you hire more engineers or other engineers. But I'm not talking about firing engineers. I'm talking about your AI team. If you think that they're doing research, that the result of it can actually benefit your business, you need to make it into a product. And to make it into a product, you need some engineering infrastructure over there. So you have an ML ops team, an ML engineering team, and in addition to your data scientist, and in addition to other engineering teams you have. They might reporting, like organizationally, where do they report different cases, and we can debate this forever, and I don't think there's any standardization in that so far. But you do have engineers that will consider like their KPIs. I need to make AI work, right? This is my KPI. This is how I'm measured. And then your second question was about feeling the pain. And so I did say it's a trend, and I do want to say it's a trend that is still in its beginning. Okay, for sure, the market is a bit early for this, and where we see businesses realizing the pain most, like strongly is where there's an AI solution already out there in the wild that's actually bringing them a big chunk of their value. And they've seen a couple of problems, and they have like an internal project to try to monitor this, and it's kind of really, no one really wants to do that. That's where we see like the most adoption at this point, yeah, for sure. But that goes across the entire industry, right? Small startups all the way to government agencies, right? It really depends on the use cases.
Slowly approaching to the stage. One more round of applause for Itai. Thanks a lot.
Thanks.
So just a quick reminder, I hope you come back early enough so you don't miss the first part of the presentations after lunch. So enjoy.